All right, we're going to look at break-even point. If you've taken finance, you probably have done this before, but break-even is just the point that your product breaks even. That is, it covers the cost, but doesn't have any profit or loss associated with it. So it is the level of operation in which a company's revenue and expenses are equal. At break even, a company reports neither income nor a loss from operation. And to calculate the break even in sales units, you're going to take your fixed costs and divide by your unit contribution margin. So if you want your break even in units, you need to divide by your unit contribution margin. So here's just a visual where your revenues and your equals your costs. So it's going to cover your costs. Okay, so here's an example. We have fixed cost of $90,000. Our unit selling price is $25,000. If we subtract out our unit variable cost of $15,000, we have a unit contribution margin of $10. So if you take your fixed cost of $90,000 divided by your unit contribution margin, you can see that we would need 9,000 units. We would need to sell 9,000 units to break even. So the following income statement verifies the break-even point. Take 9,000 units times how much you sell them each unit for, $25. So you get $225. Variable cost, remember it was $15 per unit. Times that by 9,000, you get $135. So your contribution margin would be $90,000. Your fixed cost is $90,000. So that shows you that your income from operations is $0. So you had just enough to cover all your costs. So this is a way to check it to make sure that there's nothing left over. It breaks even. Now, if you want to figure out how to calculate the break-even sales amount in dollars, instead of the number of units, you want the number of sales dollars. You're going to still take your fixed costs, but this time you would divide by your contribution margin ratio. Okay, and then the way you get your contribution margin ratio is you divide your unit contribution margin, divide it by your unit selling price. So here, to get the contribution margin ratio, your unit contribution margin was $10 and your unit selling price was $25. So your contribution margin ratio would be 40%. Now that you have your contribution margin ratio, you can find how much sales dollars you need to break even. Take your fixed cost, divide by your contribution margin ratio, 40% or 0.40. If you change it to a decimal, and we need sales of $225,000 to break even. So I call this the contribution margin ratio approach, and this is what you do. Instead of wanting to find out the quantity to break even, you want to find out how much in sales dollars to break even. So remember, you take your contribution margin divided by selling price to get your contribution margin ratio. Then divide your fixed costs by the contribution margin ratio to get your break even in sales. So we learned that fixed costs don't change within a relevant range, but they can change because of other factors. So maybe advertising campaigns, changes in property taxes, or changes in factory supervisor salary. So they can change, and we need to see or learn the effect of change in fixed cost on break-even point. If fixed cost goes up, then your break-even point is going to go up because you're going to need more to break even because you have more costs to cover. If fixed costs go down, then you won't need as much to break even because you don't have as much fixed costs to cover. So here we see that we're wanting an additional $100,000 for advertising. So your unit contribution margin is still going to be $20 because this is going to be a fixed cost. But now your fixed cost is going to go from $600,000 to $700,000. So if we take our fixed cost, it was $600,000 divided by 20. We only needed 30,000 units to break even. But if we do this advertising expense, our fixed costs are going to go up to $700,000. So when we divide now, you can see that our break-even sales in units, we're going to have to sell more units to cover that. Now, unit variable costs remain constant over a relevant range, but they can change. If direct materials go up, then we may have to, our cost per unit may increase, wage rates may increase. So what happens is the same. If we have more unit variable costs, then break-even is going to have to go up. If the unit variable costs go down, we don't have as much to cover, so break-even would go down. And here is an example here of that. Now you see here that your unit variable cost went from 145 to 150 because we're doing an extra 2%. So an extra 2% of our selling price, because we're doing commissions, 2% of your selling price would be an extra $5. So now our fixed costs aren't changing, but our unit contribution margin changes because our unit variable cost changes. So you're going to divide by your contribution margin here, which changed, and it shows you we have to sell more units to cover that increase in variable costs. The same thing with unit selling price. If it goes up, if we increase the selling price, then we're going to have more dollar amount to cover the break even. So if we go from 50 to 60, now we have a bigger contribution margin, which is going to give us more to work with to cover those fixed costs. So here's a demonstration of that, and you can look over that. So you can see that as fixed costs change and unit variable costs change, the break even changes with it. But the unit selling price is exactly opposite. The more you sell your product for, the less you'll need to break even. There's an inverse relationship here. So here's an example exercise for you to work, so you can pause it and work it and let me know if you have any questions. We're going to move on to target profit. So in the previous slides, we were talking about your target profit was 0 because we wanted to break even. But what company is just going to want to break even? Not many, right? They're actually going to want to make a profit. So we can use these same tools that we used previously, but plug in a number amount of profit and figure out how many we need to sell to make that target profit. So the information is no different, so I'm not going to go back through it, but instead of 0 being our target profit up here, now we're going to plug in what we want our target profit to be. So here we want our target profit to be 100,000. And we solve and we see that we need to sell 10,000 units to make a profit of 100,000. So here's just the income statement showing you that. You can plug it back in. Your 10,000 units. Plug that 10,000 in each time and figure it out. And it should get you to 100,000, which is what we want for our target profit. So we can do this for our contribution margin approach and our contribution margin ratio approach, but we're adding 100,000 in there, and we can see here that we would need 750,000 of sales to get our target profit of 100,000. So a cost volume profit break-even chart, it's mostly called or sometimes called a break-even chart. And so what you're going to do, step 1, the volume in units of sales along the horizontal axis. Okay, so here is step 1. Here's your units of sales. It's going across here from 0 to 10,000. And then on the vertical axis is your sales dollars and your cost dollars. So you're going to have one sales line per unit and then one total cost line. And then where these two intersect is your break even. Now notice that your total costs start at 100,000 because that is your fixed cost there. And then it goes up with your variable cost by your variable cost. So where your line intersects is your break even. And we found out earlier that our break even was 5,000. I believe we calculated that. Let me go back and see where that was. Okay, our break even was 8,000. Hold on, I gotta go back even further. That was okay. Our break even was 9,000, so this must be a different example here. Okay, yeah. So it's telling us here that our break even was 5,000 units. So we are using I skipped a few slides, we're using a different information here for Munoz Company. So the total fixed cost was 100,000, and then the sales price is $50 per unit. So it's going to go up $50 per unit. Unit variable cost is $30. So when we do our costs, we're starting at 100,000 because that was our fixed, and then it's going to go up. And it's going to go up by $30 per unit here. So this is what a cost volume profit chart looks like, or a break-even chart. So we're going to look at one more thing in the next video. I want to talk about your cost volume profit analysis assumptions. And then we're going to do some walkthrough. We're going to do a walkthrough exercise.